Next, let us discuss about the general procedure for strength measurement. You are using strain gauge to measure the strength of a testing material. This is the process that you can go through for you to do the measurement. Let us go through the procedures. First, you determine what is to be measured. What is the purpose of the measurements? The level of accuracy required, and etc. Knowing this will help you to select suitable strain gauge for the measurement. Bear in mind that not all the measurements of the strength require strain gauge. Depend on the level of accuracy required. Dynamic gauge can also be used. Or if you are measuring the crack width, there are also ways to measure the crack width of concrete. The bottom line here is you need to know what you are measuring, why you need to measure that, and decide whether strain gauge is suitable before you proceed with the following steps. Strain gauge itself is a consumable. Once it is used, you cannot reuse it, and it is very expensive. It normally comes in package of 10 units, and it is not cheap. Not many research projects have this luxury to do measurement on strength using strain gauge. You only use it when it is really necessary. Next, you will need to survey the measurement conditions. What type of material are you measuring? How about the shape and dimensions? The temperature, the atmosphere, the moisture conditions, and etc. This will govern your decisions in selecting the right strain gauge, using the right adhesive, as well as the right coating materials to protect the strain gauge. Next, it will be the selections of the strain gauge. You will need to select the right strain gauge, deciding on the gauge length. Consider the effects of thermal, whether you are using uni-axial gauge or multi-axial gauge. And then for multi-axial strain gauge, you have staggered type and plane type strain gauge. This is very much dependent on the purpose of the measurement, as well as the materials of the test specimen. You will need to choose the right adhesive to ensure the bond between the strain gauge and the testing material. Some are applicable for steel, some are applicable for plastic, and so on and so forth. You will have to consider the lead wire as well as the coating materials. The coating material provide protections to strain gauge from moisture, from abrasions, and so on and so forth. You will need to consider whether the strain gauge is to be embedded within the test specimen or it is merely on the surface of the test specimen. For example, some strain gauge is attached to reinforcement bar. The strain gauge will need to be protected with suitable coating material. Leave the lead wire out before you cast the concrete. While casting the concrete, be careful with the regions that you have the strain gauge installed. Any damage to the strain gauge will result no readings can be acquired from that strain gauge. You know that the wire is also very thin, easily broken, and it is connected to the strain gauge at the gauge tab. This is very weak. Make sure you protect it well while preparing for your test specimen. Some strain gauge is installed on the surface of the test specimen. Under such circumstances, coating material may not be necessary. It depends on the situations. And then you need to determine the strength and the temperature measurements method. Next, you will need to plan out the installations procedures. You need to plan properly the sequence of installations, as well as how you ensure the safety and well-being of the strain gauge. and then you will need to install the strain gauge. Follow the standard procedures of installing the strain gauge. There is a series of strain gauge, another series of adhesive, and also various types of coating materials. Know the proper handling method for the strain gauge. Strictly abide to the installation procedures so that the strain gauge firmly attached to the test specimen, well protected, and remain in good conditions so that you can acquire result from the strain gauge during testing. Next, it will be the testing stage. You test the specimen and you measure the strength. Depending on the situations, such as the temperature, adjust the related factors accordingly to correct the results. After the measurement, it will be processing the data. Based on the strength acquired, you are able to compute the stress. Based on the readings given by the strain gauge, you can tell when the testing material yielded, and so on so far. You might also need to check the validity of the data through calculations or some design standards to see if the data is reliable. Always be skeptical with the data. You cannot assume all the data are right and reliable. Maybe you overlook certain procedures. Whenever you acquire the data, check if the data is logical and cross-check with the other aspects during the testing. Based on what you have observed during the testing, based on the failure mode of the test specimen, as well as based on the readings given by the other measuring device, you can do the cross-checking and you can more or less tell whether the data is logical and reliable. Lastly is removing the strain gauge and cleanup. This one is depending on the situation. If you are going to continue using the test specimen, then you will need to remove the strain gauge properly. However, if your specimens are tested to failure, or your strain gauge is embedded within the test specimen, probably you don't have to remove the strain gauge, as eventually the specimen will need to be disposed. Make sure you dispose the specimen properly. Abide to the disposal procedures as stipulated by your institutions or university.